Hello, students. This is Saxon Algebra 2, Lesson 81b, Products of Complex Conjugates. We've already learned that mathematicians are very finicky about what is allowed in a denominator. For example, they abhor seeing a radical in the denominator. And so they can take care of that very nicely by, they found mathematical ways to take care of that very nicely. Now, it turns out that they also abhor seeing a complex number in the denominator. In this video, we will see how the technique of finding the product of complex conjugates allows mathematicians to eliminate a complex number from the denominator. First, what are conjugates? Conjugates are easier to explain by using examples. With real numbers, the conjugate of A plus B is A minus B, and the conjugate by the same token of A minus B is A plus B. In a pair of conjugates, the numbers are always the same and in the same order. They are conjugates because one pair is a sum and the other pair is a difference. This pair is a sum, that pair is a difference. The cool thing about real conjugates is that when you multiply them together, as we already know, we get the difference of two squares. Now, what about complex conjugates? Well, obviously, complex conjugates are conjugates of complex numbers. So in general form, we have A plus BI and A minus BI. The very useful thing about complex conjugates is that when you multiply them together, you get a real number. The imaginary part disappears. Okay, let's try it. Okay, I'm going to multiply this together and I'm going to get A squared. Then I'm going to get minus ABI. Then I'm going to get plus ABI. Then I'm going to get minus, and I'm going to put it in parentheses because it's two terms, BI squared. Now, look at that. We see that I've got a minus ABI and a plus ABI, ponga ponga. The I term goes away. Now, we have to deal with this one because an I is trying to sneak in there. We're not going to permit that. So remember that I squared is the square root of minus 1 squared. And that's the very definition of like squaring or square root or something. You have to look it up in your book. I don't remember right off the top of my head, but the upshot is that when you have a square root that is squared, the answer is whatever's inside of it. So I squared is equal to minus 1. So let's see what this does for us. So this gives us A squared minus, well, we can distribute this, B squared times I squared, which is going to give us A squared minus B squared times minus 1. So look what happens with complex numbers. You don't get the difference of two squares. And I think there was a time when some of you asked about the sum of two squares. So now you can factor the sum of two squares, but you're going to get complex conjugates. So, because when I do this, I'm going to get A squared plus B squared. So look, so when you multiply complex conjugates together, the answer is the sum of the two real numbers. And that is how we are going to help mathematicians all over the world to get over their peak whenever they see a complex number in the denominator. They're not finicky about numerators. Remember that. You can have complex numbers in the numerator. It depends on the problem. Just like the example that I showed you with radicals that made them so happy. There was a radical in the numerator, perfectly fine. It's denominators that mathematicians are finicky about. So I hope this video was a help to you, and I'll see you next time.